Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2002 Ford Excursion. This Excursion has a V10 6.8 engine in it, and this V10 has a stalling problem. It's intermittent apparently. Vehicle is here from another shop, so we need to figure out what's wrong so we can fix this vehicle. First thing I want to do is get a scan tool and get some basic data. So let's go ahead and get that scan tool connected. Okay guys, I got the scan tool, I got it up, we've got good fuel control, we're switching, we're centered, and the long and total trim are both good. Bank to bank is good. We just started it, so we're warming up still. Charging system is good. We have a code set and the monitors haven't been run. We know that they've been working on the car, so I'm not worried about the monitor, but I do want to see the codes. Okay guys, so we got a code for the transmission output speed shaft sensor signal. Okay guys, now right now you would say, oh, how can that speed sensor cause this car to die? But let me tell you, you better be worried about that code for this car stalling. You know, most people would look at that and blow it off, like, where's my crank code? But if the output speed sensor is breaking down, and I've seen this where the speed sensor is breaking down, the output speed sensor has a higher rotational count than the input speed sensor, and then it shows the tranny is slipping, so they cut injectors on the motor to try to limit the torque so they don't burn up the transmission. On more modern cars, they don't cut the injectors, they close the throttle blade on drive-by-wire. But this isn't that new a car, this has got a Bowden cable. So I'm worried about this code right now. I want to look at one other thing. This car sort of feels like it's running rough to me. Everything looks good. Let's go to mode 6. And I want to just see if it shows any misfiring. It's really hard to feel a V10 miss. Okay, so the codes have been cleared, so there's nothing here. Nothing is filled out, so the codes took all this data away. But it sure feels like I've got a really, and it's really slight, it's hard to feel. But it just sort of feels like a really light miss on this car. But I'm not going to get involved in the miss right now or anything like that. We know our trims look okay. So the trims are okay, so I'm not going to freak out right now on whatever is causing this light miss. But what I am worried about is the output speed sensor. Because if you're going down the road and that sensor breaks down, it'll want to cut the injectors. Well, what I've seen is on cars where you just start to move, if it cuts the injector, the car will die. You know, they're not, whoever programmed this, you got to think about how things are programmed, guys. When you program the car, you're not thinking that the sensor is going to break down and it's going to get the wrong count of the output speed sensor. You're thinking that when you're going down the road, the transmission starts to slip, and I have a different count base between the two sensors, input and output, and then the tranny slipping, so I got to protect the tranny. And to protect the tranny is to cut the torque from the motor. So I want to get a scan, I want to get my scope, and I want to get on this output speed sensor. I want to look at that signal to start with. So let's go ahead and do that first. Okay guys, I brought up a wiring diagram and I got the output speed sensor signal, and it's a dark blue yellow traced wire right here. Now the last one of these I did, that sensor is on top of the tranny and it is hard to get to. So rather than go that route, I've gone ahead and I've gotten into the wire that goes to, I found the wire and I found the harness as it goes down to the tranny, and I'm in the wire. Now to make sure that that's the signal I'm looking for, I'm going to jack the rear of the car up and I'm going to run it with the wheels turning so we can check this signal, because what I need to know is what's happening to this signal. But I've seen these sensors go out and the sensor starts to break down and it'll cause these cars to stall. It's something I've seen in the past, so we're going to start there. So I'm in this wire right here. Let me show you that wire. Okay guys, here's the wire that I found. That's dark blue with a yellow trace, and this is the harness, and that harness trace, that goes to the tranny. So that wire right there goes to the transmission. So I'm pretty sure I'm in the right wire. But now I'm going to go ahead and jack the car up, and we're going to turn the wheels to make sure I've got the right signal. Okay guys, I need to jack the rear of this car up so I can spin the tires so I can check that sensor. Okay, so I'm going to pull this into gear so I can spin the tires. Now this is going to set an ABS code, but that's okay. I'm not worried about that. I just want to check the transmission output speed sensor. Okay guys, so I'm in the wire and I'm in it. The red light's out. The other thing I didn't show you is the negative lead is on the battery. The only acceptable place when you first start to work on a car to have your scope lead is on the negative post of the battery, because I don't know if I've got any voltage drops yet until I've confirmed my grounds. Until I do that, I always get on the battery ground so I don't get burned. So I'm in the signal. So what I want to see now, and I've got the tire turning, and okay, so we've got the signal here. Okay, look at that. Look at these spikes coming out of it right there. So right away, okay, so right away, that looks like an ignition hit on this to me. Those definitely look like ignition hits. And we can see they're riding. And not only are they up here, but they're down here. So now I want to do something else. I want to go ahead and I want to run a frequency plot to where we're going to plot the frequency. Let's do that again. We can see these spikes. Look at that, where the frequency jumps way up right there. Gonna run the frequency plot on this. Look at the frequencies plots. Every one of these is changing the frequency, and you see how it's jumping the frequency all the way up? Well, this is my shaft speed down here with where these spikes from the ignition is hitting, and we can see how high it's getting here. So that's definitely, the computer's going to see that. But I want to, let's go back and look at this again. So we can see these spikes right here. Look at all these ignition spikes in this waveform. See all this noise in there? Those are ignition spikes, guys. Let's go ahead and run the plot, the frequency plot. That's what the computer's saying, because it's counting edges. It's saying the shaft speed is all of a sudden way elevated. Now this isn't the sensor breaking down. This is not the sensor. This is ignition noise riding on the signal. So what I want to do is I want to go ahead and stop the wheels from spinning. Okay guys, so this is the signal right here. Okay, now look at how big some of these are. They're bigger than the other ones. So what I need to do is I need to figure out which one this is, so I need a sync. So I'm going to get on the #1 coil so we can sync it. So let me do that. Okay, so I've gotten in the #1 coil with the #2 channel, which is red. So that will give me the trigger from the #1 cylinder coil. Okay, the red trace is the #1 ignition coil. Okay, so there it died already. So let's see what we've got here. Okay, so we got a pretty big hit right there, and that lines up right with the #1 coil. We can see that that guy got a hit right there. Look at how big that one is right there. That's really big, and that's big enough to start worrying about because I can count it. These others, I can see the ignition all the way through here, But do you see how I can see that one's really big? So what I want to do here is I want to go back out. Okay, I want to mark that because that's the cylinder that it is. It's way, way bigger. I'll show you again, but let me first dial in. We need a firing order. And this is a V10, 165-1027. That's the firing order, so we're going to mark it. Okay, so that ignition coil is number 9. Right there is on number 9. So we're going to come and zoom in on this. I'm going to remark that. So it brings that firing order marking down. Do you see how that's 9? So that's 1. The red one's 1. That real big one is on 9. So 9 is the one I'm worried about now. So let's just see if we got any others. You can see right here again where 9's a big drop because that's 1 and that would be 9. Again, do you see that the one right before 1 is 9? So that's 9 again. So I've got some other ones, but the only ones that are really like they're going up high enough, I think, to be counted or to be in that wave to where I'm going to count them with the engine or with the transmission control module, PCM, the powertrain control module in this car. I definitely can see where 9 here and here were big, and that's right before it died. So I think that that's what's going on. So now I want to get in number 9's coil. So let me do that. Let me get in number 9 ignition coil. Okay, I've gotten into the number 9 coil right here with channel 3 green. Okay, now the green trace is in number 9's ignition coil. Go ahead and start it. So load it. Now I can already see 9 kicking way down right there. See it in the green? Okay, so there it died. Right there it died. So now I'm going to take the zoom window and we want to just look at this. First, let's look down here and just see what we've got. Look at how you can see those big 3 strikes and they line right up. They're lining right up with the number 9. So those are my coil strikes right there, and we can see that they're bigger than like 1. They're bigger than the rest of these. Look at some of these over here. That's really big. So we can see that those are riding in there and they're aligning with that fire of the coil. The coil is firing, and you can see the first strike, the second strike, they're clearly here in the sensor reading. Okay guys, do you see how this is kicking up? That looks lean right away. That cylinder looks lean. You can see it's got a kick up. But normally when I got multi-strike, the one I want to look at is at the end. It's the last one. And you see how we just came way up? We didn't even get a burn. There's no plasma. That plasma, it looks lean. But let's just look at a couple of these and try to figure out what's going on. We got a little turbulence in there, and we got it kicking up. That's smooth, and that one looks good. Again, this one looks like we're having a really hard time firing. That first one is really having a hard time striking, but look at all this turbulence there. Now guys, let's look at a couple of things here. So one of the most important things to look at is this amount of energy that's being right here. That's being reabsorbed into the coil. Whatever energy couldn't make it across the spark has to be reabsorbed. Now that reabsorption is really small. So that tells me I don't think that that's turbulence and lean. What I think that is I think this is a carbon arc. That's a carbon arc right there. Because if it wasn't a carbon arc and I had a lot of turbulence, it wouldn't be able to dissipate all the energy in the coil. And then that spike, that negative going tail would have to be bigger. With that much turbulence and that short a period of burn, the tail would have to be bigger if that really is going across the spark plug. So I don't think that's going across the spark plug right now, guys. I think that that's got a problem to where there's some kind of a carbon trace I'm going to. That's some kind of carbon track, I think. That's after it died. Again, we look lean there, but I don't got any turbulence. Okay guys, is what I want to do is I want to snap the throttle and put a load on this, and I want to look at it with a light snap. So we're going to go ahead and put it in fast capture. Go ahead and give it a light snap, Taz. Look at all this turbulent activity right in here. We snap it and we got a lot of turbulence. Okay, now that might be some kind of a valve that could do that too, because I can get turbulence from being really lean, I can get turbulence from a valve, or I can get turbulence from a carbon trace. Now, the thing that makes me think different is I don't have a big tail on any of these. So I think that's some kind of a trace, and I'm dumping all my energy because I don't got a tail. Okay, look at how heavy the turbulence are right there. Really, really heavily turbulent with no tail. Now that I don't think is turbulence. I think that's carbon tracing in the coil or the plug, or there's some kind of a trace right here. I don't think that that has to do with a bad valve, but I want to do one more test. A really good way to load coils is to crank it with the throttle wide open. So we're going to try that. So let's do a cranking wide open. Go ahead. Okay. Okay guys, look at how much turbulence that's got, because we got the throttle wide open, so we got a full load, a full compression pressure, and it's putting the coil under load, so that's arcing. Now again, I think that if we look at the amount of energy at the tail compared to how much turbulence I got, that's a carbon trace. But if you thought that that was a cylinder, we just cranked it and we had that problem, so we're going to rule that out. We're going to come over here. Okay, so now is what we want to do, guys, is I want to run a compression test. So to run a compression test, I got to take the number 1 lead and I got to connect it to the battery positive, the negative on here, and you got to have a coil on number 1. The firing order was already picked, so we're ready to do this. Go ahead and crank it. Long crank. I'll tell you when. Okay. Okay, there's no low cylinder here. They're all good, and the one I'm mainly concerned with is 9, and I've got really good compression. So I do not have a compression loss, and we know that 9 has turbulence cranking wide open. So we just did a test with it wide open and we had heavy turbulence. So I'm going to tell you this isn't leaking. That's what that's going to tell me. So okay, now I want to show you guys a really cool trick that I learned many years ago. About 20 years ago, I had a car that was really kicking my butt, and I couldn't understand what the amp clamp was telling me, and then I saw that it was a coil that was bad. So if these coils carbon trace and they're inside the coil and it's arcing inside, and I think the only way I can get that big a hit on that crank sensor is if that coil is arcing internally from the secondary to the primary. I think that's what I'm looking for this problem. So if it is, we can use an amp clamp to do that. Okay guys, I want to take the amp clamp and I wanted to put it around the negative battery cable. So that's my 600 amp clamp around the negative cable, and then I'm going to set the scope up for that amp clamp. Yeah. Okay, so I've got an amp clamp on the negative battery wire, the main wire that goes to the battery that's negative. So let's go ahead and fix this. So we got the 600 amps, so we got that there. Then we want to go ahead and run it. Go ahead and start it. You see these big strikes that are coming through that line up with that number 9 coil? This is on the battery, negative battery wire. Do you see how none of the rest of these are that big? You see some because you always have current has to go back to its source, which means it goes back. But you can see some of these are bigger. They're just bigger. See how big these are? See how small all these other coils are? Well, that's got a big hit. And to get that kind of a hit on the negative battery cable, that is a coil that's shorted on that cylinder, which is the number 9 cylinder. Now, I want to go ahead and we're going to do a quick snap on this car. Go ahead and snap it. Look at where we snapped it. Look at how big those guys got right there. See how the amp clamp is picking that negative energy up? And it's just during the burn time, right? Do you see where I sparked? Watch this. So that's my burn, and that's when the amp clamp is seeing it because I've got current. But all of this hash, that's a carbon arc, guys. That's carbon arcing. And I can find that internal arc with an amp clamp. It's really a crazy trick. When I figured this out, it started to make all these type of problems that I come up to much easier. Because rather than disassembling everything, I know what's going on by using the equipment. It's always a matter of using the data and believing in your equipment. You'll always fix the cars. So that coil on number 9 is going to have to be replaced. Now the next problem that you've got is we need to probably put the coil and the plug in 9, but we probably have a problem because to arc through a coil, it has to have really had some hard hits. Like maybe that cylinder is lean. We're going to have to figure that out, but before I can do that, I need to put a coil in here, and then we'll run these same tests and I'll show you what the difference is when the coil's not bad. So let me get that coil in here. Okay guys, so we know that the coil is bad now, so now I got into some of the injectors. Okay guys, so now we're on the injectors and a couple of coils, and we can see that the amp clamp on blue, that's on the negative position of the battery, and we can see that it just died right there, it just stalled. Okay, so let's look at this. See how we have these injectors right here and here and here, and they just stop? And when they just stop, I still had coil strikes, but the engine died because we're not fueling it anymore. separate these. Okay, do you see how the injectors were just shut off and they just barely started to come back on? Now guys, this is to reduce the torque output from the engine so you don't burn up the tranny. Think about this as an engineer. The engineer is worried about the tranny slipping, and if the tranny is slipping, and the only way he has to see that is the input speed against the output speed sensor of the tranny. The only thing he can do is to limit the torque. So this is the torque limiting. That's commanding a torque limit. But when the engine's not going down the road, because he figured this strategy is when it's going down the road and it's under power and he sees a differential between the output speed sensor of the tranny signal and the input signal. And then the tranny's slipping. So as soon as he sees the tranny slip, he's going to shut these injectors off. And again, you can see these big coil strikes that are aligning right with the number 9 coil. And that's the amp clamp around the battery cable, the battery negative cable. And we can see that it lines up. Notice how all the big blue strikes are only lining up with the number 9 coil, not with the other coil strikes. That's because that number 9 coil is bad. I think it's internally arced. And it's going from the secondary to the primary and it's hitting it. And that's what usually causes when I see this type of a signal with the amp clamp. I've done this quite a few times, guys. That's usually where my problem is. But you can see the torque limit command, and that's just because this signal is getting contaminated with the ignition. And those ignition pulses are edges that the computer counts, and all of a sudden it thinks that the shaft is going much, much faster than it really is. So now what I want to do is I want to put a scan tool on here, and I want to show you guys what a scan tool will show you. Okay guys, this is a scan tool I've brought up for the vehicle. I've got the output shaft sensor, that's the output, and the turbine is the input. So I've got input and output. Now, okay, just stalled. Look at that. 6,000 RPM. Do you see how it thought it's going 6,000 RPM? The difference? Well, that's the tranny slipping. So clearly the only strategy that an engineer can do is to limit the power. You got to limit the torque production from the power plant. Guys, this is simple. Understanding how things are programmed makes things so much easier to fix. If you don't, you need to take some classes, get some books from the SAE. Start reading them. They'll explain some of these strategies in the books. But this is a basic strategy to keep the transmission alive. That's all it is. But this is great, isn't it? Watch this. This is just great. Okay, now, so I got my scan tool, and I could check my speed sensor. Wow, okay, so I see my speed sensor go to 6,000 RPM, but I still would have no idea what's causing it. Once you have a scope, I can actually determine what coil is bad, so I only replace the bad coil. We're gonna fix this car quickly and effectively. Okay guys, the shop has gotten a new Motorcraft spark plug and coil. These are OE components. They've installed a number 9 on this engine now. So channel 1 is on the transmission output speed sensor. This is on number 1 coil. This is on number 9 coil. So what I want to go ahead and do is we want to do the cranking wide open test like we had previously done. Go ahead and crank it wide open. That's good. Okay, so right away we want to just come in and take a look at this. Now we can see that there's not all the hash or the carbon track is not there now. So we can see that we burned across, and even though we burned with the time, do you see how we have a little tail? You always want to look at the tail, the time to the tail. If I have a really short burn, it's got to have a bigger tail if it's got a lot of load against it. So right now I can clearly see that we don't have the carbon track there. It doesn't have what would look like turbulence. Here's one. Let's go back out here. We don't see a little bit of turbulence, but nothing like it was before. So definitely, and the car is fixed. The shop is telling me since they put this in, it's not dying anymore, it's fine. Okay, now let's go back out here, and what I want to do is we want to come down. The yellow is the sensor. So now the biggest strike down is from the number 1 coil, and we saw some of that earlier, but now the number 1 coil is getting more energy into that sensor, but at least we don't have 3 large strikes in a row off of the number 9. So we can see right here, that's where the number 9 coil was, and it doesn't have the great big ones, but we do still have 3 pretty big ones off of 1. So we're going to need to look at that. So let's go ahead and do a quick snap and see if it's lean, see if 1 is loaded due to it being lean. Go ahead and start it and give me a little snap. Okay, so what we want to do is we want to look right over here. When we first snap, it's the most likely place to find a problem. And right here I can see, look at how lean that number 9 is. You see how 9 is coming up? So that's lean there. So 9's really lean right there, guys. Look at that. Look at how high it's going. Okay, so let's mark that one. That's a lean cylinder. And I know it went across the plug because look at the tail. Do you see how deep the tail went? It went across the bottom plane for the sensor. It had so much problem discharging the energy because it's so lean that the tail, I couldn't get rid of all the energy, the reserve capacity in the coil, so the coil has to reabsorb it. That's the negative going tail. So this is really having a hard time to discharge. Now that's what I expected to see because 9 carbon traced the system. And if 9 carbon traced this, that's always caused because I have a hard time getting the energy out of the plug, and then the energy is looking for an easier place to go than to go across that plug. So right here the energy is going across the plug, but that's a new plug and coil in there. Okay, so that's okay, and I can see that it's having a hard time. Now that injector has a problem. Clearly has one. And 1's pretty lean right there. So you see how 1 is coming up? It's not nearly as bad as 9 is, but that's lean. So we have a lean cylinder on 2 as well. So we got a couple of cylinders here that look lean, and the car has 200,000 on it, so probably there's lots of lean cylinders would be my guess on this vehicle. Here we can see both of them giving a kick up, like a little lean kick here, and we've got a little bit of tail on 9, harder discharge. See how I have a bigger tail than on 1, so lean. 9 is a little leaner, and this probably is the leanest one because that's the one that carbon traced. But we're going to need to do something to clean these injectors before we return this car to the customer. So we can see that we got rid of all the what we would call turbulence, but really is what that is a carbon trace. When you see all that turbulence with very little tail, that's a carbon trace. Now these aren't carbon trace now, and the car is not dying. And more importantly, when we shut these off here, so more importantly here is how big these are. So we can see that these are much smaller than they were. They're not nearly as big. I don't think the computer can count these edges. So if the computer isn't going to count these edges, I think we're going to be okay. And we know we're still having quite a big hit because these coils are having problems because I think the injectors are dirty. But these aren't going to be big enough to count. I don't see any of these like what they were before, where they're really large. I can see the strikes on the ignition in all of these, but none of these are big enough, I don't think, to be counted. So I think, and that's the worst case, because this is snap. This is wide open snap. This is going to load the coil as hard as anything. So I think we've got the problem fixed, but it's going to come back if we don't clean those injectors. So let's take a look at that scan tool now and see what happens with it. The car's not dying anymore either, so it's fixed. Here we have our scan tool data. The blue is the output speed. That was the one that we would just see shoot up. I'd barely load it by turning the wheel, and that would load the coil enough to where it would count it. I'm in gear. Now before, all I had to do was move the wheel and it was dying. Now we can see that we're not counting any pulses. The computer's not seeing that as a bad signal now. Okay, so now the problem is fixed and it's not stalling. That's why I was hired, is to figure out why the car is stalling. The coil and the plug fixed the stalling issue. Now is what I need to worry about, is to make sure that we don't get this car back. So let's go ahead and put some fuel cleaner in the tank and go drive this and see if we can't clean these injectors easily. Hey guys, we know the fuel injectors are partially dirty because the cylinders are lean. We can clearly see that on the scope. How I want to take care of that is 505 CRF, carbon remover for fuel. Now this is not based on PEF technology or polyethylenes. This is a totally different blend that actually solubilizes and dissolves carbon. This will actually clean the injectors and the carbon anywhere this gets, and since it's coming out of the injectors, it should clean the injectors. We got about 1/4 of a tank, and that would be the most desirable. Have about 1/4 to half a tank and put one in. Now I'm going to go drive the car and then we're going to check it with a scope. Okay guys, we've put the 505 CRF in this vehicle, and I didn't drive it. The shop owner, he lives like 30 miles away from here, so he drove it home and back down. So this car has almost 80 miles on it now. So let's see what we've got. So we want to go ahead and we want to start the fast capture, and now we're going to give it a quick snap. Okay, so that's a good hard snap. Let's take a look right here in the beginning where we first came into it. Let's see what we've got. Okay, that looks way better. It doesn't come all the way up like we were seeing before, at least on that one. And we can see right here where we dump most of the energy out of that coil. Do you see that reserve capacity? I don't have it. The downward slope isn't very big. And again, one has a little bit of leanness. The reserve capacity is okay on that one though. Again, it's a little bit showing lean, but nothing like it was before where it was really lean. That's okay for a snap to look like that, because that was a pretty hard wide open snap. And we can see that we have a little reserve capacity. We were able to dump most of it. It's not having a hard time dissipating that energy. That's what that reserve capacity, this downward, this negative movement right here. If this was coming way down to this line down here, it would show that I'm having a hard time discharging. Right now I'm able to discharge, and I can tell that by that downward peak. You can see how this one's a little bit bigger, and you can see how much leaner one looks. That one right there, that's pretty lean. That makes me, I think we're going to need to retreat this with 505 CRF with another can. One's still lean. And you can see that it's a little bit leaner. It's still the reserve capacity. I dumped most of the energy because that didn't come way down. It's still okay, so we're still okay. But this, guys, that's lean on cylinder 1. And the car does have 200,000 miles on it. I think we just need to treat this again. And here 9 doesn't show so lean. The reserve capacity is small. I've got a little bit more reserve capacity. I'm reabsorbing that energy with the coil. It's a little bit bigger. And we can see that 1 looks pretty lean right here. 1 looks pretty lean right there. So we still have some lean cylinders, but when we're snapping it that hard, we're doing pretty good right now. And here 9 looks okay. We've dissipated most of the energy across the burn. Very little negative going tail. 1 has a little bit bigger of a problem, a little bit harder. 1 looks like it's still a little lean. I think 9's going to be okay now though. And 9's the one I'm mainly worried about because it's the one that carbon traced. Here, this one looks fine. We dumped most of the voltage or the current out. The reserve capacity of the coil was dumped because we have a very small downward going tail. That tells me that we're getting rid of the energy across the burn of the plug, which is what we're looking for. When the tail gets too big, it's telling me I have too much energy. It's having a hard time dissipating all the energy across the plug gap. Now that's pretty good. Now again, this one's a little worse, but that was a pretty hard snap, guys, so I don't know. I think I'm okay. I think this car is ready to release. Here, we're not going totally lean again. We've good reserve. We're not totally lean. This is better over here. Here, it's a pretty good burn. We dumped most of the energy out of the coil, very small reserve. Dump most of the energy out of the coil, very small reserve. So guys, this looks really good. This car has 200,000 miles on it. We only put 1 can of CRF, 505 CRF in here. And for a 200,000 mile engine, it might take a few cans. So what I want to do is add another can before we deliver it to the customer so it'll clean up a little bit more as the customer drives this vehicle. But I'm confident that I'm not going to get this car back right now. 9 looks just fine. 9 is okay, so I'm going to be okay with this. Okay guys, this Ford's all tied up. We're going to give it back to the customer. This is a great Ford, isn't it? This V10, these are great engines. They make a lot of power and they're pretty bulletproof. This guy had a problem with a stalling issue. And you know, the biggest problem is if you didn't know how to diagnose a car, this car could get a lot of components put on for a stalling problem like we've seen on this car. Now, if you use an event-driven diagnostic plan where the test drives the diagnostics, as I've laid out here, you can see this is a very simple diagnostics. This car is not complicated. It was very simple to diagnose this car. As long as you use a diagnostic-driven plan and you use a scope, you too will be successful diagnosing cars like this in your shop.